we are going to study limits of trigonometric functions. We know that trigonometric functions play a major role in calculus. Okay. So here differentiation or integration applications everywhere trigonometric functions are there. So it's very important. So here now we will study limits of trigonometric functions. Okay, here we will find the limit of some trigonometric functions, that is the some standard formulas. Okay, trigonometric functions standard formulas. So here before that let us go through a theorem, that is let us take two functions f of x and g of x. Okay, let f of x and g of x be two functions of x, any functions of x. Okay, so here if f of x less than g of x for all x, okay, if f of x less than g of x for all the values of x of domain, okay, then and limit x tends to a f of x and limit x tends to a g of x exist. Okay, if f of x less than g of x for every values of x in domain, limit x tends to a f of x and limit x tends to a g of x exist, these two limits exist, then we say limit x tends to a f of x less than limit x tends to a g of x. Okay, here if f of x less than g of x and these two limits exist, okay, then limit x tends to a f of x less than limit x tends to a g of x. See, this theorem is for to find the relation, that is inequality of trigonometric functions, to find some inequality of trigonometric functions. Okay, now let us go through that. So remember, if f of x less than g of x and these two limits, limit x tends to a f of x and limit x tends to a g of x exist, then limit x tends to a f of x less than limit x tends to a g of x for some a, okay, not for all a, for some values of a. Okay, here we have taken a unit circle with center O and x is the angle x radian. Okay, so here first of all, okay, here the range of x is 0 less than x less than pi by 2, isn't it? See, x is always less than pi by 2, less than 90 degree. Okay, so the x range is between 0 pi by 2. Okay, 0 less than x less than pi by 2. Now here we can write, see, what is the area of the see here CD and AB are perpendicular to OA. Okay, O is the center of this unit circle. Here we can write area of triangle OAC, that is less than area of, see here look at this carefully, area of triangle OAC, it is less than area of sector OAC, right? Area of a triangle OAC means only this much, that is always less than, that is area of sector OAC. Sector OAC means the area will come to this, up to this, right? Okay, so here area of a triangle OAC less than area of sector OAC, that is less than, see, we can write, obviously it is larger, right? So OAB, area of triangle OAB. Okay, now here what is the area of the triangle OAC? See, triangle OAC, CD is the height of this triangle. So we know the area of the triangle, that is half into height into base, right? So here we can write half into, height is CD, okay, triangle OAC, height is CD. So CD into base is OA. Okay, that is less than. What is the area of the sector? See, in our trigonometry functions chapter, we have already studied area of the sector of a circle with the angle theta, that is theta divided by 360 degree into pi r square. isn't it? So here 360 degree we can write it as a 2 pi, right? 2 pi is 360 degree. Okay, so theta by, here theta is the angle, so here is the x is the angle, right? So here we can write x divided by 2 pi into pi. What is r? See, r is nothing but OA, right? Radius of the circle OA. So OA square. That is less than, okay, area of the triangle OAB. Triangle OAB is nothing but it is the right angle triangle. Since it is right angle triangle, directly we can write half into OA into AB. Okay, AB is the height, right? So half into OA into AB. Okay, see here 1 by 2 cancelled, here pi cancelled, okay, and OA, here 1 OA cancelled. So we can write it directly, that is CD, okay, less than, okay, CD is remained here, half is cancelled, X, it is 2 cancelled, okay, here 1 by 2 cancelled, X into OA less than AB. Okay, now let us consider the triangle OCD. Okay, triangle OCD, it's a right angle triangle, right? So since it is right angle, let us write the ratio of trigonometric functions. So what is sin x? Sin x, see what is sin x here? Opposite side divided by hypotenuse, right? So opposite is CD, CD divided by hypotenuse is OC, right? So that is CD divided by OC is the radius of the circle, right? So here we can write OC or OA, right? So OC is equal to OA. So here we will write OA because see in our inequality OA is there, right? So we can substitute. So sin x is equal to CD divided by OA. Therefore CD is equal to OA into sin x. Okay. Then next here let us consider the triangle OAB. Consider the triangle OAB. Okay. That is here what is the tan x? Tan x is equal to opposite side divided by adjacent, right? Opposite side divided by adjacent. See, it is the angle x, okay? So tan x is equal to opposite by adjacent. So opposite is AB divided by adjacent OA, okay? Therefore here we can write AB is equal to OA into tan x, okay? Now let us substitute this CD and AB here, okay? So what we have got CD is OA into sin x less than x into OA less than AB is OA into tan x. Okay. See here in 3 terms here inequality OA is there, right? OA is common. So we can cancel this OA. OA cancelled. Okay. Now remaining sin x less than tan x. Okay. And here, see, we know that the x is nothing but here it is the angle, right? So this x, the range of x is 0 to pi by 2. 0 to pi by 2, that is first quadrant, right? 0 to pi by 2 means first quadrant, right? Here, if it is the circle. So 0 to pi by 2 means all the trigonometric functions lying in first quadrant. So in first quadrant, we know that all the trigonometric functions signs are positive, right? So here, since it is 0 to pi by 2, here let us divide this throughout by sin x. Okay, because we can divide because sin x value is positive, right? So let us divide throughout by sin x. What we will get? Sin x by sin x divided by sin x less than x by sin x less than tan x by sin x. Okay. Now here we have here divided throughout by sin x. So that is sin x by sin x by sin x less than tan x by sin x. Inequality will not change because the sin x is the positive. Okay. So it becomes okay. Now it becomes 1 less than x by sin x, okay, less than tan x by sin x. Tan x is sin x by cos x. So sin x will cancel. So 1 by cos x, 1 by cos x. Okay. Then 1 by cos x. So here now let us take reciprocal of this. Okay, here all these terms are positive. Okay, let us take reciprocal. See, when we taking the reciprocal in inequality, the inequality will be changed, right? So here when we take reciprocal means 1 by 1, okay, inequality will change. That will be less than will be greater than. Okay, x sin x by x, sin x divided by x greater than cos x. Okay, so once again we will write cos x less than sin x by x less than 1 by 1 is 1. Okay, now here see we have got an inequality cos x less than sin x by x less than 1. Okay, that is cos x less than sin x by x less than 1. Okay, see just before we studied, we learned that f of x, if f of x less than g of x, then limit extends to a f of x less than limit extends to a g of x, right? So here also, if three functions also, see here this also we can say if f of x less than g of x less than h of x, then limit extends to a f of x less than limit extends to a g of x less than limit extends to a h of x. It is called the sandwich theorem. Okay. So here if f of x less than g of x less than h of x, then limit extends to a f of x less than limit extends to a g of x less than limit extends to a h of x. So same here we can apply this one. Here let us take limit extends to 0 cos x. See what is limit extends to 0 cos x? Let us find it. Okay. Limit extends to 0 cos x, that is substitute x is equal to 0. See whatever limits you are, if you are asked to find, first you apply the direct substitution method. Okay. So here let us apply direct substitution method. Put x is equal to cos 0. Okay. That is cos 0 is 1. Right. So when applying this method, so we have got 1. So that is the answer. Right. So limit extends to 0 cos x is equal to 1. Okay. So here let us take limit, okay, for this inequality. So here limit extends to 0 cos x less than limit extends to 0 sin x by x less than limit extends to 0 1. Okay, it is 1 itself, right, because it's a constant. Okay, so here it says that it is limit extends to 0 cos x is 1. That means that is not exactly 1. Okay, limit extends to a f of x is equal to f of a means that is approaching to f of a. Okay, not exactly f of a. Okay, so here also limit extends to 0 cos x is equal to 1 means that value is approaching to 1. Okay, that is very close to 1, not exactly 1, it is close to 1. Okay, so here this value is, it is close to 1 and it is 1. Okay, it is exactly 1. So it is less than 1, okay, and greater than of this. That means this value is near to 1. Right? It is also very close to 1. So here obviously we can write this. We can say limit extends to 0 sin x by x, that is also very close to 1. That is also approaching to 1. Okay, that is the value of limit, right? So limit value, that is not exactly now limit extends to a f of x is equal to f of a means that value when x tends to a, when x approaches to a, f of x approaching to f of a, not exactly f of a. F of x approaching to f of a. Okay, so here also, here this cos x is approaching to 1. Okay, that means let us take one example. It is approaching to 1. Suppose let us take it is 0.98. Okay, then it should be greater than 0.98, right? Okay, let us take if it is 0.999. Okay, so see here, it is also approaching to 1 because it is less than 1, right? It is less than 1. Okay, therefore it should be less than 1 and very close to 1. So here we can say, we can write limit x tends to 0, sin x by x is equal to 1. So it is the very important, that is the standard trigonometric limits formula. Okay, it is the limit of trigonometric function formula. Okay, here we have got an important trigonometric limit, that is limit x tends to 0 sin x by x, that is equal to 1. Okay, so let us find another important limit, limit x tends to 0 1 minus cos x divided by x. See here we can write 1 minus cos x as 2 sin square x by 2. Okay, that is we know that 1 minus cos 2x is 2 sin square x, right? Okay, so from the trigonometric identities we have already learnt that in trigonometric functions. So here we can write it as 1 minus cos x. 1 minus cos x is equal to 2 sin square x by 2. Okay, here 1 minus, if it is 1 minus cos 2x, see this is the formula, 1 minus cos 2x is equal to 2 sin square x. Okay, when it is 2x, it is x, it is the half of this one. Okay, so here if it is x, it is x by 2, half of x, right? That is x by 2. Okay, so here 1 minus cos x can be written as 1 minus, 2 sin square x by 2 divided by x. Don't forget to write the limit. Okay, limit x tends to 0, 2 sin square x by 2 divided by x by 2. Okay, see here, not x by 2 here, x. Okay, x itself. Okay, that is equal to, see here we can write this 2 will be here, right? See why? Because we know that denominator of denominator comes to numerator, right? So here we can write, we can take these 2 here, denominator of denominator, right? So here we can write it as limit x tends to 0 sin square x by 2 divided by, let us take this 2 here. Okay, we can write it divided by x by 2. Okay, we know that denominator of denominator comes to numerator, right? So that here we can see why we are writing this one. See, we have to make this in the form of this one. Okay, this limit, then only we can apply the limit, right? Okay, so here we can write one more step, that is limit x tends to 0 sin x by 2 divided by x by 2, and one more sin x by 2 is there. Let us write it here, sin x by 2. Okay, and one more thing, see in algebra of limits we have written that is limit x tends to 0 f of x into g of x is equal to limit x tends to 0 f of x into limit x tends to 0 g of x, right? So here we can write it as limit x tends to 0 sin x by 2 divided by x by 2 into limit x tends to 0 sin x by 2. Okay, so here this one we can apply directly, see from this one, right? We know that limit x tends to 0 sin x by x is equal to 1. Then limit x tends to 0 sin x by 2 divided by x by 2. See, it should be same, right? Okay, so sin x by diagonal should be same. Okay, sin x by 2 divided by x by 2. Then it is 1. Okay, apply this standard formula. Okay, so limit x tends to 0 sin x by 2 by x by 2 is 1. Okay, so 1 into, here apply limit. See, just apply direct substitution method, put x is equal to 0. What you will get? X sin x by 2, sin 0 by 2, sin 0 by 2 is 0. So sin 0 is nothing but 0, right? So here we can write it is 1. 1 into 0, that is 0. So remember, limit x tends to 0, 1 minus cos x divided by x is equal to 0. So these are the two important limits. Limit x tends to 0, sin x by x is equal to 1. Okay, very important. Limit x tends to 0, 1 minus cos x divided by x is equal to 0. So just see, keep it in your mind, then you can find this one. If you know this one, limit x tends to 0, sin x by x is equal to 1. See, from this you will find this one. Okay. So limit x tends to 0, 1 minus cos x divided by x is equal to 0. Okay, now let us apply this formula to for some problems. Okay. Okay, now let us go through some questions. First one, evaluate limit x tends to 0, sin ax by bx. Okay, first of all, let us apply direct substitution method. Apply x is equal to 0, substitute x is equal to 0. So that you will get, see, sin 0, sin a into 0, sin 0 is 0. And denominator b into 0, that is also 0. So we will get 0 by 0 form. Okay. So after that, we will apply another method. See, on seeing this, you should see here, it is of the, we have to make it in the form of this one. Okay. Apply standard formula. So here, sin ax by bx, right? We know that our formula is limit x tends to 0, sin x by x is equal to 1, right? So here, if it is sin ax by ax, we can write 1, right? That is limit x tends to 0, sin ax divided by ax, that is equal to 1. Okay, now let us write ax here. So if we write ax, then we have to multiply ax, right? That is, we can write limit x tends to 0, sin ax divided by bx as, okay, limit x tends to 0, sin ax by ax, okay, see, divided ax, so I have to multiply by ax, okay, divided by this bx, okay. Then now we can apply. So here we can write this x will cancel, okay. Then, and this a by b is a constant, right? We know that, see, in our algebra of limits, we have written this one, limit x tends to a lambda into f of x is equal to, we can take this constant lambda outside from limit. So, limit lambda into limit x tends to a f of x, right? So, here also a by b is a constant. Let us take it from, take it out from limits, that is a by b into limit x tends to 0, sin ax divided by x. See, what is this one? It is in the form of this standard formula, that is limit x tends to 0, sin x by x, right? So here sin ax by ax, that is 1. So a by b, this a by b into 1, that is a by b. So a by b is the limit of this function. Okay, now let us go through second one. See, second one is limit x tends to pi sin pi minus x divided by pi into pi minus x, right? So here, see, if you put x is equal to pi, what you will get? See, first of all, you have to apply that method, that is direct substitution. You have to substitute x value. So here, sine of pi minus pi, that is 0. So sin 0 is 0. So numerator becomes 0. Here denominator, what about denominator? Here see, pi minus pi, 0. 0 into pi, 0. So here also we will get 0 by 0 form. Okay. Now let us apply another method using standard formula. So sin is there. So here, see, for here we have to apply this formula, here we have to make 0, right? Here we have to make 0 and we have to make this expression in the form of this one, right? So here let us take x is equal to pi plus y, okay? Let x is equal to pi plus y, so that this pi will cancel, okay? So let us write, okay? See, if x is equal to pi plus y, then x is equal to pi, so y tends to 0, right? Okay, now we will get that one. So when x tends to pi, okay, we have taken x is equal to pi plus y, okay. So if x tends to pi, so this will also change, right? Okay, if, when this variable change, so this limit will be changed, okay. So here x tends to, when x tends to pi, y tends to 0, right? Because see, substitute x is equal to pi, so that we will get x y is equal to 0, right? So if x tends to pi, y tends to 0, okay? See, whenever variable changes, this limit will be changed, okay? So remember, don't write the limit as it is. So here limit will be changed. So now here we have got a y tends to 0. Okay, now let us substitute these values here. So it will become limit x tends to, sorry, not x tends to, y tends to 0. Okay, x tends to pi implies y tends to 0. Okay, y tends to 0 sine, see, pi minus x, so that is pi minus x is nothing but pi plus y, okay, divided by here pi into pi minus x is nothing but pi plus y, okay. That is equal to limit y tends to 0 sine pi minus pi is, that is cancelled, so minus y, okay, sine of minus y divided by pi into minus y. See here 1 by pi is the constant, okay, 1 by pi is the constant, so we can take it out from the limit. So here we can write 1 by pi into limit y tends to 0 sine of minus y divided by minus y, right? See, now it is of the form this one, that is limit x tends to 0 sine x by x, right? So here we can write limit y tends to 0, the value of this limit is 1, right? Limit y tends to 0 sine of minus y divided by minus y, that is 1. Okay, because it is of the form this standard limit. So it is equal to 1 by pi into 1, that is 1 by pi. So 1 by pi is the limit of this function.